Today we are going to do section 4.1 and 4.2. But before we do that, I want to review some stuff. So please turn to your book to page 105, which is the second half of section 2.2. I don't normally do this, but today it is necessary. Okay, so we'll go over some old concepts very quickly that will be needed in today's lesson. So on page 105 in your book, you will see the slope of the line, which we did some time ago. Right? What was the slope of the line? The slope of the line, if you have 2 points, x1 at y1 and x2, y2, the slope will be calculated by calculating the difference and then dividing. That is, m, the slope, is going to be equal to y2 minus y1 over x2 minus x1, which is what I have written here as well. So that is that. So with that, as you can see in example 8, that we can, if we are given 2 points, then you can calculate the slope very quickly by following this formula. Okay, and then the next thing is we can then, with this information, we can also calculate the equation of a line. The equation of any line with the slope is given like this. That is, you pick 1 point and you have the slope, then you write down the equation as x minus x1 times m equals to y minus y1, which is what example 9 did. We did this before, so we're not going to repeat that. But I just want to remind you that we did do this once. Now, if this looks unfamiliar, that's okay. All right, here is the point slope formula on the following page, okay, which is what I wrote on the board. The point slope formula is y minus 1 equal to slope times x minus x1. And with that, you can calculate slopes of various things that's given to you, such as example 10, where you find the equation of a line that once you're given a slope and 1 point. All right, and that is on page 106. So, but we're not going to do any of this, okay? I just want to remind you that we did this at 1 point. Or example 11, the equation of a line passing through 2 given points. To calculate the line that you are given 2 points, you find the slope first with the 2 points, and then you plug it into this line equation. So that's example 11. And then let's flip the page. Next, example 12. Writing the equation of a line in the standard form. What's this? Excuse me. What's the standard form? That's the ax plus by plus c business. Okay, you just rearrange things so that it looks that way. And we did that at 1 point, and we don't have to worry too much about it right now. And so the next thing, a vertical line is something. For example, a vertical line is always in the form of x equal to some number, such as x equal to, say, 5 or minus 1 or 0, whatever. Anytime you see a line written like that, that means it is a vertical line. And then the next, we also learned. Well, whatever. Whether two graphs are perpendicular or parallel. Okay, let's look at the following page. Flip a couple pages. Where does it say that? Well, anyway, the point is 2 lines are parallel. I'm now on page 109. Now, 2 lines are parallel if they have the same slope. Okay, that's the graph demonstrating that fact. And then 2 lines are perpendicular if their slopes multiply to become -1. Okay, so you have 2 lines, one have slope m1, the other one have slope m2. If they multiply to be -1, then they are perpendicular. So that is and then example 14 at the bottom of the page show you how to determine if you're given 2 lines, whether they're perpendicular, parallel, neither, whatever. And so that is that. Next, you can the following page 110, where example 15 writes the equation of a line that's parallel to some line and passing through a given point. And yeah, we did that. So if you don't remember exactly how to do that, don't worry about that right now. Okay, I just want to remind you that we have done it, and if you need to remember how to do that, just refer back to this example. So yeah, so flipping the page. Next, I'm on page 111, example 16. And the equation of a line perpendicular to some other line and passing through a given point. Same thing. Is we will basically always use this particular equation. Okay, it's good for any and all things. So keep flip. Okay, that's the end of this page. And next, now I'm on page 233. You don't even need to turn to that page. I've written down here. I just want to show you something real quick. That is the average rate of change. This is section 3.3, where we learned the delta y over delta x business. That is, what is delta y over delta x? Remember, delta y is one variable. It's like saying Mr. Smith is the name of one guy, okay, not two guys. So delta y is one variable, and delta y means y2 minus y1, whereas delta x means x2 minus x1. Okay, so the average rate of change, which is the slope, okay, at the time I mentioned that it was the slope. So you can also call this delta y over delta x, or call it the rate of change. This is something we did back in section 3.3, as I've shown here, and it's on page 233. But that's all I want you to know about that. Now with that, we have finished section 4.1. Why? Because section 4.1 is a complete recap of what we learned in section 2.2, I think this is, and when that little bit from section 3.3 or something like that. Anyway, with that I just covered. So which is why we're gonna, now that I mentioned all this stuff, we're gonna skip over section 4.1 and go straight to section 4.2. So please turn your book to page 362. Now, section 4.2 is called Modeling with Linear Functions. And what does that mean? It means what we used to call word problems. Yay! And so with that, let's go to page 362 and we'll look at example 1. Okay, now let's see. A town's population has been growing linearly. That means we're going to use this equation. This is the linear equation, okay, to model the town, if you want to call it that. Now, in 2004, the population was 6,200. 2009, the population is 8,100. So you need to predict the population for 2013. So I have information written down here. Now we are going to so this will be x1, okay? The year will be x1 and x2, and the population will be y1 and y2. So to write this equation, our first goal is to calculate m, which is following this formula. Then m equals to so we'll call this, okay, subtracting. So 81, okay, 8100, and we'll subtract by the 6,200, and then so then 2009, okay, minus 2004. Yeah, okay, that should be good now. So that would be equal to, by the time you do some math and realize this is something about 19 or something, divided by 5, 1900, right? And that would be equal to some number. And we'll write it as, well, we'll figure that out later. Anyway, that's our m. Now that we have figured out the m, our job is to predict the population at 2013. Okay, so what we're going to do is write down this equation. Okay, so we have y minus y1. Where's y1? That is 6,200 is equal to m times, following this equation, m times x minus x1. x1 is 2004, right? That is, yeah. Anyway, maybe I should write the numbers out properly. This is 2004. Okay. Anyway, so we have our equation, which is good. Where m, we have calculated m equals to 1900 over 5. So I should probably write that down. M is 1900 over 5. Yeah. Anyway, so then the next thing we need to do is, now that we have our equation, we need to know what y is when x is 2013. So we'll write this down. So 1900 over 5, and x is 2013, okay? And then is subtracted by 2004. And this is still the same thing. All right, so by now, then we just have a bunch of math to calculate. So we'll write down y be 6200. We'll push it to the other side of the equation, and then plus this pile of stuff. Okay. Yeah. Oh, I guess I'll write it down again. 5, and then 2013 minus 4 is 9, right? I believe. Okay, so that will be a little better. And that equals to whatever it equals to. So let's pull out the calculator and do some math. Okay, I found my calculator. So let's do this. 62, oops, I need to turn it on first. Okay, try again. 6200 plus 1900 times 9 divided by 5. Okay, so that's what I got here. See, I have the whole thing typed in precisely. Let's see, yeah. And then let's push the equal sign and see what it says. All right, so I came up with a number. Let me write it down. So I got that number and I checked with the book and it is correct. Yay, that is always awesome, right? So let's look at the next part of the problem. It says they want to know when does the population reach 1500? So the population is the y value, okay? So we have this equation here and we need y to be, what was it, 1500? 15,000, sorry. So y need to be 15,000, okay? So we'll write down 15,000 minus that thing, that's our equation, 6200. And that equal to that pile of stuff, okay? So it's 19, I'll write this again. Divided by 5 times x minus 2004. All right, so if that's the case, in this case, then we're going to solve for x. So basically, we're going to solve this equation. And then, well, in that case, we just have to, well, do some of these calculations, okay? Well, being that this is kind of a big number, let's do this. So 15,000 minus 6200 is, this is 88, okay, so we have 88, yeah, 100. Okay, we'll move the 5 across, that becomes multiply. And move the 1900 down, that becomes divide, okay? Be sure you know how to do this. When you move a number across the equal sign, when it's multiplying, you will push it down below the division line. Similarly, but anything that's under the division line, you move across to the top, okay, and then becomes multiply. And this is also called cross multiplying. But anyway, so that equal to x minus 2004. And then eventually we have then 2000, x will be equal to, x will be equal to this number plus 2004, okay? So we'll write down 2004. So I punched out this thing on the calculator, okay? There is here's what I did. As you notice that that it equals to 23 point whatever that is at the end. So it says 0.1, but there's a 5 below, so I'll take it as 0.2 to round things up. And that is, so it's 2004 plus 23.2 is the x number of years, which is something like 2027.2. Okay, it's the year that the town will be, whatever it was, 15,000 population, which is what we are looking for. Now, so let me check to see if, this is, my calculator is sitting in a weird spot. Yep, 23 point something. And so 23 years after 2004, which is 2027. So we are correct. That is always great, right? Now you might say that, well, I can totally do this problem without any of these fancy equations, which you can, okay? And the equation just make everything in a systematic way, so you don't have to think or anything, okay? And that is, you can just plug this equation into a computer and then punch in some numbers and out comes the result. That is the benefit of using a set mathematical model that you can just calculate everything and don't have to worry about, oh, how much is it increasing per year and all that stuff. And you're basically doing the same thing, though. That is what this is calculating, is the m calculates how much is the rate of increase, and then you calculate the difference and multiply. You're doing the same thing. So anyway, so that's that. And let's move on to example 2 after I erase the board. So next, let's look at example 2 on page 364. We have two people who started at the same intersection. One, this is Emmanuel, who is going south at 3 miles an hour, and then Anna is going east at 4 miles an hour. So then, but there's a limit to how far they can be apart. They can be no farther apart than 2 miles. So then, so how far can they go, right, before they reach the limit? That is the question. So let's say they walked for how many hours? Let's say X hours before they get to the point, X hours, okay? And after X hours, Anna would have gotten 4 times X, right, going this way, okay? So this length is 4X. And then whereas Emmanuel would have gone south 3X. So that length here will be 3x, and then together it can be no more than 2. Okay, so 4x plus 3x had better not can be at the most 2 miles. That's it. Okay, and so so the question is, how far? Well, how many hours did they walk before they reach that point? Well, then we have 4 plus 3. That's 7x. Why do I have 3 there? I said 7. Okay, so 4 plus 3 is 7x equal to 2. So then x equal to 2 over 7, that's hours. That is, after 2 over 7 hours, and after 2 over 7 hours, then, sorry, what am I? I've lost my mind. I forgot to do the Pythagoras theorem, for heaven's sake. 4 plus 3 is not 2. We need to do this, right? What happened to the Pythagoras theorem? It's a squared plus b squared equal to c squared. Okay, I told you a while ago that you must never ever forget the Pythagoras theorem, and now I'm losing my mind. Ugh. Anyway, let's get rid of that. That is completely ridiculous. Ugh. My eraser fell off. Okay, the Pythagoras theorem, which I didn't really forget, I just lost my mind for a second, which is, it says that a squared plus b squared equal to c squared, c being the longest side of a right-angled triangle. And this is a right-angled triangle because the people are going straight east and south, okay? So we are going to do this instead. That looks much better. So then now we got 4 plus 3 is that equals to 16 plus 9 is 25. X squared equal to 4. So x squared equals to 4 over 25. Okay, and then x then equal to squared. X then equal to 2 over 5 hours. Yeah. All right, that sounds a bit better. Okay, 2 over 5 hour. That's 24 minutes or something. Yeah, well, whatever. It's 2 over 5 hours, and that is the answer, which, that looks much better, right? And so next, let's look at example 3. We have a road leading from some town that's from one town to the other town that is okay, let me read this question more carefully. Or we can just draw this thing out, okay? Now we have the town W, Westboro or something like that, okay? We have a town W, and then leading to town A, which is 30 miles east, and that's not all. It's also 10 miles north. All right. So that the town A is 30 miles east and 10 miles north. All right, that's better. Partway down this road, it junctions with a second road perpendicular to the first, leading to the town of Eastboro. Okay, now let's look. There is a straight road leading from the town of Westboro to Agrietown, 30 miles east and 10 miles north. So this town W to town A is a straight line. All right, so we'll draw it that way. Okay, and that town is the town A is 30 miles east of W and 10 miles north of W. Then partway down, there's a second road that's perpendicular to the first, that leading to the town. So there's partway down, there's a second road. Okay, let's draw it maybe right here, doesn't matter. And the town to town Eastboro. So there's town E, and town E is directly east of town West, 20 miles east. So this is 20. So this short distance here is 20, whereas the whole thing is 30, and that part is 10. Now the question is, how far is the road junction from Westboro? That is, how far is, this is the junction, we'll call it J. So the junction is right there, and then we have to calculate this distance right here, okay? Okay, then let's see, to do that, we have to know some things from geometry. Yeah, I don't think, what? Give me a second, the book draws something different. Okay, actually the book is right. It says that the way it reads, it says this second road is perpendicular to the first road. What that means is the perpendicular, quality is, well, something fell. Anyway, the perpendicular quality is perpendicular here. That is, this thing here is perpendicular. All right, so far so good. Right, but either way, we're gonna need some geometry to be able to pull this off. Okay, and then, so then we have, let me see what the book wants me to do. All right, now your book wants you to do this without geometry, which I have never seen before for this type of problem. So what I'm gonna do is show you how this problem is normally done, and then we'll do it the way the book does it, okay? So that you get the best of both worlds. So first, the way this problem is normally done, in my experience, is that we calculate the distance from W to A, okay? So that is this whole thing, which by the Pythagoras theorem of this rectangle means this whole thing, we'll call it D. Let's call the whole the whole distance D, okay? And we'll call this thing, which is what we're looking for from here to here, X. So the entire distance will be D, and then D equals to, by the Pythagoras theorem, D squared equals to 30 squared plus 10 squared, okay? And then so when you take, which is that's D squared. So D equals the square root of these two things, and that equals to some number that we'll calculate in a second. So once we figure out what D is, then we are going to realize that there's a certain proportion going on. That is, this rectangle, okay, is the long end, that is 30 over D. Here's this proportion from similar triangles. That is, if you take this 30 divided by D, okay, this proportion here, 30 over D is the same as the X over 20. X is what we're looking for, and furthermore, we already know what D is. So as a result, X equal to 30. Let's see. We'll take 20 up here. Okay, is 20 times 30 divided by D is what X is, and then I will use my calculator to figure out what that is. So I punch the numbers in, okay, and the calculator, which says that if you have, let me move this over here. The calculator is too reflective, and my camera can't focus very well. Well, you can kind of see it anyway. So you have 20 times 30, which equals to 900, okay, and divided by 900 plus 100, which is 18.97, and that is actually the right answer according to the book. So that is wise. Okay, so I will write that down here. This thing is 18.97, whatever. And whatever that is, miles, something. So that is the answer, but however, the book doesn't want us to do similar triangles, and it wants us to do our lines, okay? So we will follow the book along and do it their way as well. Now, according to the lines then, so at first we're going to calculate the equation of this line if we assume that this is the origin, okay? And that is, we gave coordinates of these points. So this point A will be given as 20, 10, okay? Point A will be called 20, 10. And then, yeah, something like, sorry, did I say 20? I mean 30, because it says 30, okay? So, which your book also has a graph that looks much better. So look at that if my graph doesn't look as good. Whereas the town W, Westernboro, it will be called 0, 0. That will be the origin. And Eastboro will be called 20, 0. So we'll call this thing 20. Why is it 20, 0? Oh no, that's this thing. Because over here is 30, 0, right? But we don't care about over there. We only care about the E guy, okay? E guy is as 20, 0. All right, so first we're gonna write down the equation of this line right here, okay? And the equation of that line, to calculate it, we first calculate its slope will be 10. For that line, okay, the slope, we'll call it M1, because we will have another slope coming. So M1, which is 10 is rise over run, okay, which is 10 over 30. And that will be equal to 1/3, which means the equation of this line, we can call it y equal to 1/3 of x. So that's the first line. And this is the line from W to A. I'll write it this way, okay? From W to A is y equal to 1/3 x. All right, so next thing we're gonna do the equation of this line. Now, we know that this line has a slope of -3. Why is that? Because a while ago we mentioned that there's a condition where perpendicular lines, this means perpendicular. Perpendicular means that if two lines are perpendicular, that means that the two slopes, M1, M2, multiplied has to equal to -1. So that the slope here, then, as a result, this we'll call it M2, okay? M2 times 1/3 has to equal to -1, and that gives us M2 equal to -3. Okay, so that's the second equation. What's the equation? That's the equation of this line right here. And the second line has the slope of -3, and it also goes through the point 20, 0. So let's do that. And so following this equation right here, okay, so what is our line? Our line, to summarize, our line M has a slope equal to -3, and it goes to the point of 20, 0. So therefore, following this equation right here, we have y minus y1, which is 0, okay, equals to m, which is -3, times x minus x1, which is 20. 20, okay, here we go. So that is the equation of this line right here. And then, and we have, therefore, y equal to -3, x minus 20. Okay, so now we have two lines. Now, if we have two lines, we can calculate the intersection of these two lines, right? We can now, yeah. And so we're gonna do, where are our two lines? Here's line 1, okay, which is going from W to A. And here's our line 2, and that goes from W to E, all right? So, no, sorry, from J to E. So line 2 is going from J to E. not necessarily, I don't necessarily have a direction. I'm just showing you is a line that going, well, one way or the other. Anyway, so we have two lines and we have to calculate their intersection, which is fine. Let's do that. We set the two y's as equal to each other. In order to find the intersection, the two y's will be set to be the same, and therefore being that they're crossing at the same point, so they have the same y and x values. And knowing that, we have therefore setting them to be the same. We have 1/3 x equal to, that's that one, okay, and then copy this thing down, 3x minus 20. All right, so now we're going to solve this equation, which will give us, that will move the 3x to this side, okay? So it's 1/3, this 3 1/3. Yeah, 3 1/3 x, move the x over here. And then over here is minus 3 times minus 20, that becomes positive 60. So x, it will be equal to 60 divided by 3 1/3. And that can be punched into the calculator, okay? Or we can do it directly by dividing by fractions. 3 1/3, 3 1/3, that's 10, okay? 10 over 3. And then we'll flip through the inverted multiply trick, which is 60 times 3 over 10, okay? That is equal to 18. So x will be equal to 18, and y, where's y? Y is equal to 1/3 of x, okay? So y would be equal to 18 divided by 3 is equal to 6. Well, that is that so far we have found the coordinate of this intersection, which is the intersection j then becomes j equals to 18, 6. Okay, which is what the book says. Okay, so far so good. And finally, what are we doing here? We are trying to calculate the distance of x, right? In other words, what is the distance from this j point, which we just calculated, to the origin? And well, we're going to do that by the distance formula or the Pythagoras theorem, same thing, and which states that the x then is equal to square root of 18 squared plus 6 squared. That's by the Pythagoras theorem. And then that equal to that will equal to the same thing we found earlier. Okay, yeah. So that would be also, if you punch it into the calculator, which I guess I'm gonna skip that for now because this problem is going a bit long. So then we'll just trust the book and say that this is also 18.97. Now, which is what we found before. Okay, this is a much longer way of doing things, but it doesn't require geometry exactly. And then we do end up using a lot of linear equations. We have to solve two linear equations, and then we have to find out their intersection, and then we have to do the Pythagoras theorem. And it's more or less what we did before too, but the geometry way is of course much faster because this is a bit tedious. But anyway, we're done with that, so let's look at the next problem. Now next, let's look at page 367 and look at example 4. But before that, I want to mention that in the previous example we did, we came up with a solution by solving the two simultaneous solutions by setting y equal to y to be equal. But that isn't always possible, okay? In our case, what happened is that those two equations, which are represented by two lines, actually intersect, so that there was one solution. However, sometimes the two solutions might be parallel. That is, so that they don't intersect at all, like ever. And then, or maybe they are they're the same equation, so there is nothing to intersect. So that is a possibility. We're not going to care that much about that because we mostly do problems that do have a solution. So, but you do bear in mind that sometimes it is possible for your linear equations to not be able to come up with a solution. So having said that, let's consider problem example 4. There are two trucking companies, okay? One guy charged an upfront fee of $20, then 59 cents per mile. And then, so that's the first company is $20, and then some 59 cents per mile. All right, this is per mile. And then the second company similarly charges less money upfront, base price, but it charges more per mile. So as you can see, if you don't go many miles, you're probably better off going with a second company, which we will call, first company is called K, the second company is called M. So then, if you only go, say, a mile or two, you're better off with the first company. If you go a ton of miles, you might be better off with the second company because they do charge less increase in the long run. The question is, when is the cutoff point? Like, how many miles do you have to go when finally the second company is too expensive? Okay, it really depends on how many miles you are planning to travel. So then we will set up the equation. So the first company we will have which is $20, right? Plus, let's say the guy traveled X miles, okay? So the guy traveled X miles. So the first, if he went with the first company, he would be spending $20 plus 0.59x, okay? And the second company is $16 plus 0.63x. Now, when these two are equal is when the second company catch up with the first company, and after that, the second company is going to cost more. So we are going to do this equation. Then will show us exactly how many miles will be when the two companies intersect. And so then let's do that. Okay. So we'll move the 16 over here. That's 20 minus 16. And this side, we'll move this on this side. So that's 0.63x minus 0.59, 9x. All right, so that would be 4. And then we need to do the 6359, that's a 0.04, right? I guess the difference isn't great. All right, so then x has to be 4 divided by 0.04, okay? And that is going to be 100, I think. So the guy, if the guy drives 100 miles or more, then he should be better off with the where the second company is going to catch up. So he's better off with a company that's more expensive up front. Now let me check. Yep, that is what your book says, and so I got that one right. And to do this division, if you're not familiar with it, what you do is you move this decimal point 2 spots, which means this equation becomes 400. That is, because you moved it 2 spots, you add 2 zeros on top, whereas the bottom is just 4, okay? Because the decimal point got moved over here, so it becomes 4. Add 2 zeros on top. For each decimal point that you move, you add a 0 on top. So then 400 divided by 4 is 100. But that is not a big deal. Or you can just use the calculator to do it, and that might be faster. It all depends on which way is easier, right? And so anyway, that we have come to the end of this section. It only has 4 examples, but the example 3 sort of took me a long time because it was more convoluted. Anyway, which is fine. Let's do homework. Let's see. This homework is on page 369, right? Yes. So for homework, please do problems 5, 7, 9, 17, 29, 33, 39, 43, 49, 53, and 57. And when you're done, I want to talk about some of them. So when you're done, let's look at problem 5. Problem 5 says that we're going to do, what is that? The area of some parallelogram. We will draw it right here. So problem 5, we draw it on this side. The parallelogram is bounded by the y-axis. All right, that's this one, okay? And the line x equal to 3. So x equal to 3 is a vertical line. So here's x equal to 3. That means x is 3 and y can be anything, okay? That's why it's vertical. And f of x, some other line, f of x equal to 1 plus 2x. So here's some line we have to draw. F of x equal to 1 plus 2x. Now, to draw that line, we just need a few points, 2 points to be exact. Ask yourself, when x is 0, what is y value? Well, if x is 0, this is 0, y will be 1, okay? And then also ask, since we have x equal to 3 here, let's ask what happens when x is 3. When x is 3, 2 times 3 is 6, 7. So then y value equal to 7. So this line goes from x equal to 0, y equal to 1, right here, okay, all the way to 3, 7. So we'll draw something like that. All right, and so that is the line. We have a parallelogram that has the y-axis, has the x equal to 3, and that line, and the line parallel to f of x passing through the point 2 and 7. Okay, x equal to 2, y equal to 7. Here's 2 and 7, which, let's draw the parallel line here. So this is 2 comma 7, okay? That is, all right, so this point here is 1, because we said this is 1, okay, because this is 0, 1. All right, and then that thing just keeps going, which is a very interesting looking parallelogram, okay? But it is a parallelogram, right? Parallel to passing through 2, and x equal to 2. I don't know if I drew it right. Let me check. Yeah, I believe it's right, because I already said that this is 3 and 7, right? So 7 is over here, up here. So then this 2 and 7 will be about there. So that should be right. That should be our parallelogram. All right. So then our parallelogram is we need to know what this is. Okay, how far is that? If there's a point that passed through 2 and 7, we need the equation of this line, and so that we know where this is. Okay, so let's find the equation of this line right here. We'll call it L. Maybe not L. Well, we'll call it L. That doesn't look very good. Anyway, that line right here is what we're looking for. So that line being parallel to F, it has the same slope as F. And so the slope of f, of course, is equal to 2. Okay, so the line, I guess we'll maybe call it G would be better. Let's call it G and not L, especially since my L doesn't look the best. So let's call this line G of x. Okay, so G of x is, it goes to the point, G of x has the slope m. G of x has slope m, so m equals to 2, okay, because it's parallel to f of x, and parallel lines have the same slope. So m equal to 2, and G of x equals to, so G of x, then we'll call it, G of x equal to the same of 2 of x, and then it will follow this equation right here, okay, to be consistent. So here's y minus y1 equal to m. So the slope is m because the number in front of x is 2 here. So, but we will follow these equations to be consistent. So we have y minus, the point is 2, 7, all right, 2 comma 7, m equal to 2. So we have y minus, let's see, y minus 2 y minus 2, so that follows the y minus y1 in the equation here. Y minus 2 equals to 2 times x minus 7. And that would give us, and this y equals to g of x. So y equals to 2x, okay, minus 7 plus 2. And this is the equation for the g of x I mentioned earlier, we are doing this for only one reason. I need to know where this is, okay? Because I need to know how long this thing is. So when x is 0, so g of 0, that is, what is this point? When this point is x is 0, is equal to 2 times, what? Give me a second here. This doesn't look right. Yeah, the reason it doesn't do right is because I subtracted wrong, okay? I said y minus y1. What is y1? It's 7, it's not 2. Ugh. That's why it's not working. So y minus 7, whereas x is supposed to be subtracted by 2, okay? X minus 2, and that's the x value. All right, so that would be a lot better. Ugh. So x minus 2, and then whereas y is minusing 7, so that becomes plus 7. Okay, that's far superior. Now, so that becomes, so when we plug in x equal to 0, 0 minus 2 times, that's negative 2 times 2 is negative 4. So we have minus 4 plus 7, and that equals to positive 3. So this point is at 0, 3. And that's what we're looking for, because what we're looking for is the area of this thing, okay? So then the parallelogram is called, the area of the parallelogram is called base times height. So the A is called base times height, okay? A equals to B times H. That's the area of parallelogram. And we will consider this distance as the base. That's the base, B, which is equal to 2. So b equal to 2 because it goes from 1 to 3s. And then the height is 3. This is the height. The height, which is equal to 3. So the area would be equal to 6. Now, I know that sounds kind of weird because height usually goes up, but this time we're going to look across, okay? And across is just as good as up. So then the area of the parallelogram should be 6 units. Now, let me check.